Hey students, Friday here. The goal for the first plate of today, dinner, is to think about how natural disasters caused by earthquakes and volcanoes have affected people all over the world. We're going to see examples from far, far back in Earth's history and as recent as 2011, 2012. We're going to take a look at the eruption of Mount Vesuvius near Pompeii, Italy in CE 79, and also the Tohoku earthquake that affected Japan, especially on March 11th, 2011. So let's start with Pompeii. You may have heard of the eruption of Mount Vesuvius in Pompeii recently. In fact, here in Omaha, there was an exhibit of Pompeii artifacts that a couple years ago was present at one of the main train stations in Kansas City, Missouri. And so maybe you got a chance to go down there and see that. But what happened with this eruption? Well, in 79 CE, so nearly 2,000 years ago, Mount Vesuvius in Italy, you can see here's a map of Italy. Italy is located in southern Europe, and here in this little red box is where approximately where this section is located. Mount Vesuvius on the edge of Italy here is a volcano that is produced by a convergent plate boundary. What you have here is you have the plate where the Gulf of Naples is located sinking underneath the land for Italy. And when that rock melts from that convergent boundary, melting underneath the surface, it is less dense and rises to the surface. Now, there had been a lot of pressure that was building up in Mount Vesuvius before this happened. And in 79 CE, for several years before the eruption, Herculaneum and Pompeii experienced frequent earthquakes. And back then, people didn't really know what earthquakes were all about, but we did find evidence of repairs that happened at both Herculaneum and Pompeii of earthquakes that had happened in the 10 years leading up to the eruption of Mount Vesuvius. The only reason why we know specifically about what happened and knew to dig these cities out is because a guy by the name of Pliny the Elder, several decades after this eruption, published an account of what he had heard. He was nearby in Naples and had actually seen the aftermath of the eruption of Mount Vesuvius and was able to record that. And through ancient documents, we were able to understand what happened here, and modern humans actually had to dig these cities out. So what happened? Well, when Mount Vesuvius erupted, this was not primarily a lava-based eruption. Different volcanoes can erupt in different ways depending upon how much ash and pressure is building up within the volcano, and sometimes it can be lava-oriented like you expect for volcanoes like the Hawaiian volcanoes. Hawaii is not at a plate boundary. Hawaii is where there is a large mass of magma sitting under the surface, and that magma causes continual, very runny fluid lava eruptions in Hawaii. Mount Vesuvius is what we call a composite volcano. Composite volcanoes tend to build up pressure and build up pressure and build up pressure. Composite volcanoes tend to be on the edges of continents where a plate is sinking far underneath another plate. Mount St. Helens in Washington on the edge of the United States is another example. So Mount Vesuvius built up pressure and built up pressure and built up pressure. There were all these earthquakes that were caused by slight releases of those pressure over several years. And then finally, in 79 CE, Vesuvius erupted and coated the entire area that you see here in a dark gray black ash. And it covered the entirety of this area. It buried these cities. And unfortunately, anybody who was in this area at this time was killed by this ash. It would be like breathing in fine pieces of glass. I know that sounds horrible, but I want to try to help you to understand the nature of what was going on here. And then people would be buried in this hot ash that would have hurt their bodies. In fact, it hurt them so quickly that the way we were able to see the impacts of this eruption on people is that the people's bodies disintegrated underneath the ash, leaving a cavity that we could pour plaster into to see what their last moments of life looked like. And there will be some images of this. I want to forewarn you, if you don't want to see images of this, you might want to skip over that short portion of the video and fast forward ahead. So here's an image of modern Pompeii with people being able to walk around it. To help you to imagine what we had to do to get the city to look like this, This entire area was under 30 feet of volcanic ash, and we had to dig out and remove all that ash, in many cases chipping away at it at a rock hammer and carting it off to another location, and it was like peeling a banana and seeing what was underneath. The banana layer was like the ash, and underneath is this amazing city that was preserved in time as a time capsule. Pompeii has been exciting historians and scientists for hundreds of years. There was this huge surge of interest in Pompeii several hundred years ago, and it's really continued through the modern era. Okay, so this is a picture of a plaster cast that was taken of a person in their final moments, sort of covering their face as the ash was likely moving over them. And so you may be able to imagine what it would have been like to have this horrible experience. We have evidence of lots of these plaster casts that were taken when we first started to dig out the ash at Pompeii. Now, the next one, if you have pets, you might want to skip a short section of the video. So here's a plaster cast of a dog with its collar intact that we were able to pour plaster into the place where the dog used to be from the ash, and this is this poor doggy after it had experienced what happened with Pompeii. And then here's some people who are trying to hide from the eruption inside of an interior room. And you can see that there's both adults and unfortunately children. One of the most famous images from Pompeii is this individual in the background who's trying to crawl around or get away from this. People would have been choking, and the heat would have been so intense that the good news is that it would have killed them shortly after they began to experience it. And so the eruption of Mount Vesuvius in 79 CE is an example of the significant impact that volcanoes can have on people. But what about earthquakes, and what about the modern era? Well, that's a really good question, and so we're going to continue this story with what happened in 2011 with the Tohoku earthquake that happened on March 11th, 2011. So this image shows, this red X shows where there was an earthquake happening at the Pacific Ocean. It's really important that this X is where it is because this is a place that we would expect earthquakes to happen. And in your next plate for dinner, there are 2 plates for dinner today, big focus of that will be investigating what we can learn from different types of earthquakes that appear at different types of plate boundaries. In a prior video, I had mentioned, and you may have read about, depending upon what you chose for your way to investigate different plate boundaries, convergent plate boundaries can produce volcanic island arcs. And that's what Japan is. Japan is a series of volcanic islands that essentially rose up out of the ocean due to the effects of volcanoes. And so this convergence of the Pacific plate over on the right side of the image and the Asiatic plate on the left side of the image, this Pacific plate has been sinking underneath where Japan is located, producing these volcanic islands. And this extends all the way down to the south below here where the Philippines would be located as well. We call this area of the Earth the Ring of Fire because the entirety around the Pacific Ocean has a lot of convergent plate boundaries. Most of the divergent plate boundaries are located in the Indian Ocean or the Atlantic Ocean and up in the Arctic. Most of the convergent plate boundaries are around what's called this Ring of Fire. And the most famous effect of these this convergent boundary near Japan is Mount Fuji, a very famous volcano. Now, we're not going to be talking about Mount Fuji here because this is not an eruption of Mount Fuji. This is an earthquake that happened deep underneath the surface where this convergent plate boundary was. What was the consequences of this? Well, before we get into the consequences, one thing that I'd like you to think about is the ethics of trying to manage a population and earthquakes. Many people have a misconception that we can predict earthquakes, and the long and short of it is that we should be precise about what we can predict and what we can't predict. And sometimes it's easy for a government to fall into the trap of leading people to believe that we can predict more than we actually can. We can predict the sorts of areas on the surface of the Earth, on the crust, that earthquakes are more likely to happen in. A key example of that would be the San Andreas Fault in California. The San Andreas Fault in California is a transform plate boundary. It is a slip-stick fault, a fast-moving boundary that has a ton of earthquakes. And as a result of that, there are a lot of earthquakes in California. We all know that from our experience. Same thing around the Ring of Fire and where Japan is. It's not a transform boundary, it's a convergent boundary, but we can still have earthquakes there. So we can predict areas of Earth that are more likely to have earthquakes. What we can't predict is the timing of those earthquakes, and it can also be very difficult to predict how earthquakes are going to move through particular variations in the types of rocks that are located at different boundaries. And this is where the Japanese government is generally considered to have made a mistake. The left-hand image is the predictive image immediately after the earthquake happened of what geologists working for the government in Japan predicted the impact would be in Japan, where lighter green images are less intensity of earthquake and red is higher intensity of earthquakes. And when the earthquake happened, there were disaster warning systems that kicked into place and predicted that there would be a very limited region of Japan that would have intense shaking. And as a result of that, not as many people evacuated as could have based upon that initial warning. Well, notice on the right-hand side is the actual observed intensity of the effect of the earthquake, and there was whole parts of this region that on the left-hand diagram we see in green and light green as not being as predicted as being as significant of a shake, but you can see all the red and orange located all over the area, showing that this predictive model did not help people to encourage them to evacuate. Now, the shaking is not the only consequence of an earthquake. Notice how here on the left image, it's noteworthy to show that the Fukushima nuclear power plant is located where this radiation symbol is right here, and this is going to be important for our story a little later on. Here's Tokyo, Japan, the most famous city in Japan where there was a capital in early Japanese history, and you can see that we're a couple hundred miles away from the Fukushima nuclear power plant. So what actually happened? Well, we have to understand how tsunamis work. You may have heard of this name tidal wave. A tsunami can result in tidal waves, but tsunamis and tidal waves are not the same thing. What is a tsunami? Well, a tsunami happens when the crust of the earth at a fault thrusts upward, pushing a mass of water up that by the pull of gravity will move towards out to the center of the ocean, but also move towards the land. And this huge upward push of water results in huge amounts of water that would normally not approach the land to approach the land. And as this water gets towards the land, it can form a tidal wave, but it's important for me to point out that the tidal waves that you see in movies as tall, towering, dozens or hundreds of stories high, very scary things, can happen in Earth's history, and we have evidence from the fossil record that they have happened, very large tidal waves, but they are very, very, very infrequent occurrences. We're talking massive tidal waves really only occur once every several million or dozen million or hundreds of millions of years on Earth's ocean. We do not see them any more often than this. So the earthquake on March 11th, 2011, produced a tsunami, a large mass of water being pushed towards the land, towards Japan and other islands in the Pacific Ocean, and people had to get to higher ground on those islands to prevent the water from coming up onto the land and risking them drowning, which is the big problem for a tsunami. Was there a tidal wave that happened as a result of this? In Japan, mostly no. But as you can see from this image, this is an image of the tsunami where water basically leaked over these barriers that are constructed in Japan to protect people from surges of water happening from earthquakes. And this earthquake was so major that it pushed up so much water that this water overflowed these barriers, and anyone who was in these areas down here that wasn't up on high ground where this photo was taken would be at a threat of drowning. And so this tsunami fell over the coast of Japan nearby and also affected areas on the western coast of the United States, but not nearly as much. Hawaii was much more significantly affected, but people were able to get to higher ground. Philippines and Japan were the ones under greatest threat, and you can see this massive amount of water that is spilling over this barrier wall, threatening drowning for people. And yes, thousands and thousands of people were killed in this tsunami, unfortunately. So, why is this a problem? Well, pictured here, Japan has a major nuclear power plant. This nuclear power plant uses radioactive decay of radioactive uranium to boil water, to turn a big fan, and that turning of the fan generates electricity. That's the basics of how nuclear power works. This is a nuclear power plant that supplies power to Tokyo and the surrounding area. Well, the problem with building a nuclear power plant right on the side of an ocean is that this earthquake was powerful enough to flood this entire area. And when the area flooded, a couple things happen. If you flood something that is being affected by electricity, it can shut the electricity down. And that electricity that is used to run the nuclear power plant can compromise some of the safety features of a nuclear power plant, primarily the electrical control of cooling systems that keep the places that holds the radioactive material, preventing it from leaking out. Here's how it works. So there is a large metal enclosure filled with water, and inside that enclosure is a small capsule that contains the radioactive material that is giving off heat, just like we talked about how the interior of the Earth is heated by radioactive decay of elements inside the core. Well, it's sort of the same principle for a nuclear power plant, only the problem is that you have to keep that steel enclosure with water in it cool enough where the heat from the radioactive decay won't melt that enclosure and cause radioactive material to go all over the place. And unfortunately, that is exactly what happened here. The cooling system failed and the reactor went into what we call meltdown. Meltdown basically just means that the enclosure in which this water and radioactive material happens melts, and that radioactive material, my apologies for the bell, that radioactive material allows or escapes out into the area and can cause radioactive contamination nearby. So this image shows where Fukushima is located, where this little red dot is, and this is how the radioactive material spread out when that nuclear power plant melted down. Red is really bad. Orange, also bad. Yellow, not good for you. Green, well, the way we measure radioactive decay's impact on cells is that the greater exposure you get to the more material, the more likely it is to have an impact on your cell's ability to reproduce. And so not only can you get more short-term negative effects of radiation, like the potential of internal bleeding or your organs beginning to fail, but long-term exposure to radioactive decay can result in cancer. And so one of the things that scientists are going to be monitoring over the coming years is the impact of how this is going to increase the risk of cancer. And in fact, in 2018, reports are beginning to come out of people in Japan dying from non-direct exposure to this radiation. I remember when this happened in 2011, I was watching the news reports because as a scientist, I'm really interested in understanding the effects that this can have on people and helping us to understand how to keep people safe. There was radioactive decay detected in milk from cows in the surrounding area around this place in Japan that was a potential continual threat for people. And so people who live near the Fukushima nuclear power plant were in great danger. Another example of this was Chernobyl, which in large group, when we first started investigating radioactive decays about over a month ago, you saw a gentleman entering Chernobyl and using a Geiger counter to measure huge amounts of radioactive decay that were happening still surrounding him in his radiation suit. And so the big concern here was that Around these areas that are marked in reds and oranges and yellows, there is a significant threat. This is measuring air dose rates in microsieverts per hour, which this is a measure of radiation, at a height of about 1 meter above the ground on February 10th, 2012. So there were people in radiation suits that went to all of these areas and reported back how much radiation they were detecting after the cooling system failed in the Fukushima plant and meltdown occurred. As of March 2012, you can see that this is an image showing the spread out of that radioactive material into the Pacific Ocean. And as of 2018, when I'm making this video, very minute traces of this radiation were detected as far east as the western coast of the United States. Now, the good news is, in general, for radioactive exposure, the farther you are from the original source, the more likely the material is to spread out, and the more spread out it is, the less exposure you have to radiation. But ingestion of anything radioactive is not good for you. In fact, folks, that's why we age and die. We age and die because radiation from natural radioactive decay in the soil eventually takes a toll on our bodies, and our bodies just can't keep up with it. That is the scientific definition of death, when you've experienced enough radioactive decay from the soil around you that your cells can't keep up with it and can't continue to function. And so, thanks for watching this video. The Fukushima disaster has had a profound impact on all the countries that border the Pacific Ocean. This was an example of the threat that earthquakes pose to people. Be sure to answer the questions to summarize your understanding before moving on to the next section. But threats are not the only aspects of earthquakes to understand. In your next plate, you will see how studying earthquake waves helped us to understand a place that we can't travel to, the interior of the Earth. Thanks for watching.